So if the two lines are perpendicular, then the product of their gradient is -1. So since we know that this is what happens if the two lines are perpendicular, the product of their gradient is -1. So all we pretty much need to do is let's find the gradient for the first line. So the first line tells us that x plus 3y is equal to what? Is equal to 6. So making y the subject will tell us that 3y is equal to minus x plus 6. All I did was subtract x from both sides. Then I'm going to divide both sides by 3. So dividing by 3, I'm going to get that it's -1/3x plus 6/3. And so the gradient of this line, so the gradient m for this line is -1/3. All right. Now the next line that they give is kx plus 2y equal 12. So they give us now kx plus 2y is equal to 12. Now that you have kx plus 2y is equal to 12, what does that mean? That means that if we make 2y the subject, we're going to get that 2y is equal to minus kx. 2y is equal to minus kx plus 12. And so all you need to do now is divide both sides by 2. Dividing both sides by 2. And what does that tell us? That tells us that this is m1 and this will be m2. And so the gradient is minus k/2. All right? Minus k/2. But since the two lines are perpendicular, what we know is that the product of their gradient is -1. So that means that -1/3 multiplied by minus k/2 is equal to -1. That's what perpendicular lines mean. The product of their gradient is -1. So -1 times minus k is k, 3 times 2 is 6. So k/6 is equal to -1. And if k/6 is -1, then k must be -6. So k is equal to -6. So that's the answer, k equal -6. So we can tell them that right here. Hence, k is equal to -6. Next it says a circle of radius 5 centimeters has its center to be the point of intersection of the two perpendicular lines. Determine the equation of this circle. So we have these two lines, all right? We have these two lines and they intersect at the center. So let me draw a circle. I always like a schematic. This is the line, all right? K is -6. And so when you think about it, then really and truly, when we think about it, really and truly what we have is this is 6/2 is 3. And so we have the line 3x plus 6. So that has a positive gradient. So let me draw a line with a positive gradient passing through the center. And the other line is going to be the x plus 3y equals 6. That have a gradient of -1/3. That will look something like this. And both of them intersect at the center. Both of them intersect at the center. So what we need to do is find that point of intersection to get. We need to find that point of intersection, and then that gives us the center of the circle. All right, so let's go ahead and find the center. Finding the center, that means we solve these two equations simultaneously. So there are many ways to solve them simultaneously. I realize that we have x plus 3y equal to 6, and the next equation we have is k is minus 6x plus 2y, and that's equal to 12. Now I love elimination method, and so what I am going to do is I'm going to multiply the first equation by 6. I'm going to multiply this first equation by 6, and that is going to give me, when I multiply it by 6, that is giving me 6x plus 6 times 3 is 18y, and that's equal to 6 times 6 is 36. I love to multiply it like that. Oh gosh. Oh no, how does it dissipate? All right, so it dissipates. So let's do it again. Multiply the first equation by 6 to get 6x plus 6 times 3 is 18y. That's equal to 36. The second equation, which is minus 6x plus 2y, that's equal to 12. Now if we add these two equations, if we add them, by adding them, what we get is minus 6x plus minus 6x plus minus 6x gone, then 18y plus 2y, that becomes 20y, and 20y is equal to 36. 36 is equal to 36 plus 12 is 48, and we divide through by that, and so what we're getting is 48 over 20. That will give us y, and so y is equal to that's 2.4. Y is 2.4, or we would say 12 over 5. 12 over 5. So that is the value for y. Y is 12 over 5. Since y is 12 over 5, we can find x, because x is just equal to 6 minus 3y. So x is 6 minus 3 times y, where y is 2.4, or 12 over 5, and that will give us x. 6 minus 3 times 12 over 5, and so y, x is 6 over minus 6 over 5. That's x minus 6 over 5. And so the radius of the circle, which they said is 5, and so the circle will have equation x plus 6 over 5 square, x plus 6 over 5 square, plus y minus 12 over 5 square, and that's equal to r squared. R squared is 25. So that's what we have. Nice and easy. That's the equation of the circle. Soft. No issues at all. So nice and easy. Lovely. So let's continue with the next part of the question now. So looking at the next part of the question, it is the vectors part, and it says RST is a triangle in the coordinate plane. Position vectors RS and T relative to origin O is 1, 1, 3 minus 1, and 4, 4. Now, anytime I'm doing these questions, I love to get a schematic of what they are asking. I just love to see it as a schematic, not a rough thing, but just a sketch. So RST, R is the point 1, 1. So let's say this is when X is 1, Y is 1 here. Then this is the point R. This is the point R. And then they want the point S is 3 minus 1. So let's say this is 3. And this is minus 1. So 3 minus 1 is right here. This is S. And then they want the point T, which is 4, 4. So let's say this is 4. And 4 on the Y. Let's go up some more. So 1, 2, 3, 4. 4 is somewhere here. All right. And so this is the point RST. Nice and easy. Then they want us to, they said, show that TRS is 90 degrees. Angle TRS. To show angle TRS is 90 degrees, TRS. So this is the angle. I'm just connecting them as a triangle. It's easier this way. You can see it. So they want us to show, so based on our sketch, they want us to show that TRS is 90 degrees. To show that TRS is 90 degrees, we need to find vector SR and vector TR. Those are what we need to find. And then we can use the formula to find the angle. All right. So what we know is that the cosine of angle TRS, the cosine of angle TRS is equal to TR dot, remember the cosine of any angle is the dot product over their norms. Is the dot product, so it's going to be TR dot RS. Well, not R, it's actually SR, so it's TR dot SR, TR dot SR divided by the norm of TR times the norm of SR. The norm of TR times the norm of SR. So let's work out these now. So before we get back to this formula, let's work out all of them down here. So first and foremost, vector TR is going to be equal to OR minus OT. So vector TR is OR minus OT. That's vector TR. OR is 1, 1. So this works out to be OR, which is 1, 1, minus OT, and OT is 4, 4. So 1, 1 minus 4, 4 is minus 3, minus 3. So this works out to be minus 3, minus 3. That's vector TR. Next we need is vector SR. Vector SR. So when we need vector SR is OR minus OS. Vector SR is OR minus OS. So that's vector SR, OR minus OS. So now vector OR, which we know is 1, 1, minus vector OS. What is vector OS? Vector OS is 3, negative 1. Now 1 minus 3, 1 minus 3 is negative 2. And 1 minus minus 1, minus 1 and minus 1, that become plus, and so that's minus 2, minus 2. So now we need their vector norms. So the norm of vector TR is going to be equal to 3 squared plus 3 squared. That's the norm, 3 squared plus 3 square, all square rooted. And so the norm of vector TR is going to be equal to 9 plus 9, that's 18. So the norm of TR is the square root of 18. Nice and easy. Now we need the norm of SR. The norm of SR is going to be equal to, not vector SR, the norm or the magnitude. The norm of vector SR is 2 square plus 2 square. So that works out to be the square root of 2 square plus 2 square. That's 4 plus 4, and that's the square root of 8. So this works out to just be the square root of 8. All right, so that's what we have. So now we can go back and say, okay, the cos of TRS, the cos of angle TRS is going to be equal to the dot product, which is the dot product of minus 3, minus 3, minus 3, minus 3, dot minus 2, 2. We'll show this dot product over the norm of root 18 times the norm of root 8. And so we'll work this out. What we're going to get is minus 3 dot minus 2. That's going to be, as we can see, this works out to just be 0. Look at it. Minus 3 dot minus 2 is positive 8. 8 minus 8 is 0. So since cosine of TRS is equal to 0, then this implies angle TRS is cos inverse of 0. Angle TRS works out to be cos inverse of 0. And so TRS is cos inverse of 0, and cos inverse of 0 is 90 degrees. So this shows that TRS is 90. Now it says determine the length of the hypotenuse. Now as we can see, the hypotenuse will be TS. All right, the hypotenuse will be TS. So we need to find vector TS. Now there are two ways to do it. We don't even need to find vector TS. Since we already found TR and SR, what do we know? We know this. Since it's a right angle triangle, then applying Pythagoras Theorem, we know that TS squared, which is the hypotenuse, is going to be equal to RS squared plus RT squared. Nice, so we can find the hypotenuse already. So it's going to work out to be the root 18 squared, which is 18 plus 8, and that is TS squared. This works out to be 26. So that is TS squared. But we need TS. So we're going to square root both sides to get that TS is equal to the square root of 26. So TS is the square root of 26 units. That's the length of vector TS. Now that's the length of TS, the hypotenuse. That's TS. Nice and easy. Soft. Now we're at question 4. Now let's look at question 4. What is question 4? Question 4 says, figure 1 shows the sector OAB of a circle with center O, radius 9, and an angle of 0.7 radians. It says find the area of sector OAB. So let's find the area of the sector. Now, area of a sector, I like to call it AS. Area of a sector is equal to theta over 360 times pi r squared. So it's theta, which is 0.7 over 360, 0.7 over 2 pi times pi r squared. And the radius it says is 9. So this will give us the area of the sector. So we get 0.7 divided by 2 multiplied by 9 squared. That's 28.35 pi. So the area of the sector is 28.35 because the pi will cancel the pi. So the area of the sector is 28.35 centimeters squared. That's the area of the sector. Part 2, it says hence find the area of the shaded region. To find the area of the shaded region, area of the shaded region, I'm going to call it area shaded. Area shaded. Area shaded is equal to the area of the triangle. Area shaded is the area of the triangle minus the area of the sector. Area of triangle minus the area of sector, and that will give us area shaded. All right. Area of triangle minus the area of the triangle minus the area of the sector, that will give us the area shaded. Nice and easy. Now the area of the triangle. To find the area of the triangle now, the triangle is right angle. The triangle is right angle. So first thing I want you to picture is look at this. So this is the triangle, all right? We only know one side on the triangle. So in order to find the area of this triangle, we need to know another side, right? We only know one side. But we know that this angle is 90 degrees. We know that this side is 9 centimeters. And we know the angle right here is 0.7. And that's in radians. So we already know this side. What is this side going to be equal to? This side is going to be equal to angles in a triangle sum to 180, which is pi radians. So if it's pi radians, we know that this is pi by 2. So we know that pi by 2 plus this angle of 0.7 plus this unknown angle, let's call it x, plus that unknown angle x, we know that must equal to 180. 180 is pi. So now that we know that all of that add together to give pi, we can find what x is. So x is going to be equal to, bring over the pi by 2, pi minus pi by 2 is just pi by 2, and then bring over the 0.7, and so this angle x is 0.87 radians. This is 0.87 radians. 0.87 radians. Now that this angle is 0.87 radians, we need to find the height. All right? Need to find the height. Now look how we're going to find the height. This side corresponds to this, and so this side corresponds to this, which is the height. All right, so what does that mean? We're going to use sine rule to find what is x. We need to know what is x so we can find the area. So 9 over 0.87 9 over 0.87. And it's not 0.87, it's the sine of 0.87. 9 over the sine of 0.87 is equal to the height, over height over 0.7. So from this we can find the height. This is the sine of 0.7. So from this we can find h, and we can say that h is equal to 9 sine 0.7. 9 sine 0.7 over the sine of 0.87. That will give us the height of the triangle. Now that we get the height of the triangle, so we'll put this in our calculator. All right, so put that in your calculator and you get 9 sine 0.7 divided by the sine of 0.87. 9, my calculator, come on. 9 sine 0.7 divided by the sine of 0.87. I get 7.59. So that's the height, 7.59. Height is 7.59. All right. So what that means, so the area shaded is equal to a half the base of 9 times the height, half base times height, and the height is 7.59 minus the area of the sector, and the area of the sector which we found already is 28.35. And so now we'll put all of this in our calculator to get the area shaded. So a half of 9 times 7.59 minus 28.35, and I get 5.81. This works out to be 5.81 centimeters squared. That's the area shaded. Nice and easy. Soft. That's the answer. That's the area shaded. Now let's look at part B. Part B is trigonometry, by the way. And so the trigonometry that they're given, it is telling us that part B, it says, show that the cos of x plus pi by 6 is that weird looking formula. Let's go ahead and do that. So it wants us to evaluate the cos of x plus, what is that? Pi by 6. Now first thing is to expand the cos of x plus pi by 6, it is cos minus sine. So all we need to know that this is going to be equal to cos x times the cos of pi by 6 minus sine x times the sine of pi by 6. Cos minus sine. So it's cos x times cos pi by 6 minus sine x times the sine of pi by 6. Nice and easy. Soft. Extremely easy. So now that this is what we have, now cos of pi by 6 is the cos of 30, and the cos of 30 is root 3 over 2. So the cos of 30 is root 3 over 2 times the cosine of x, root 3 over 2 times the cosine of x, minus the sine of pi by 6. The sine of pi by 6 is a half. So it works out to be minus a half sine x. Nice and easy. Now, of course, we're going to factor out the half. We're going to factor out the half to have a half in bracket. Don't factor out the half, we're left back with cos x, well, root 3 cos x So we're left back with root 3 cos x minus sin x. And so it is shown very easy, very easy question. Soft. Nice and easy. That's the answer. That's proven. Now we have part C to do now. Let's have a look at part C. Let's have a look at part C. So for part C, it says prove that the identity tan theta sine theta over 1 minus cos theta is 1 plus 1 over cos theta. Let's go ahead and do this. To prove these things, you always start by writing down the left-hand side. So the left-hand side, as we know, it is equivalent to tan theta times tan theta times the sine of theta, tan theta times the sine of theta divided by 1 minus cos theta. So this is what we have, tan theta sine theta divided by 1 minus cos theta. This is going to be equivalent to tan theta. Tan theta, as we know it, tan theta is sine theta over cos theta. So we can rewrite the tan part as sine theta over cos theta. And of course, this is being multiplied by sine theta. But then all of this is being divided by 1 minus cos theta. Nice and easy. Now the next thing we just have to note is that, well, sine theta over cos theta times sine theta times sine theta is sine square theta. Sine theta times sine theta is sine square theta. So that's sine square theta over cos theta. And that's being divided by 1 minus cos theta. Instead of writing divided by 1 minus cos theta, divided by 1 minus cos theta, I'm going to just put multiplied by 1 minus cos theta. Because dividing is the same as dividing. My apologies here. We're dividing it by 1 minus cos theta, so it's multiplied by 1 over 1 minus cos theta. Now, first and foremost, we need to notice that sine square theta is 1 minus cos square theta. So we can rewrite this as 1 minus cos square theta. So we have 1 minus cos square theta. So it's 1 minus cos square theta over cos theta times 1 over 1 minus cos theta. This is so boring and easy. Now, we can now use difference of two squares to separate 1 minus cos square theta, as we can separate it as 1 minus cos theta, separate it as 1 minus cos theta multiplied by 1 plus cos theta. 1 minus cos theta multiplied by 1 plus cos theta, and all of this is divided by cos theta. Then we multiply it by 1 over 1 minus cos theta. Now 1 minus cos theta right here cancels the 1 minus cos theta here. So what we're left back with is 1 plus cos theta over cos theta. But 1 plus cos theta, this is what we're left back with. 1 plus cos theta over cos theta. Now I don't want to go somewhere else, so I'm just going to bring it to the top. I don't like to do that, but I'll bring it to the top right here. And so this 1 plus cos theta over cos theta, we can separate it as 1 over cos theta plus cos theta over cos theta. But cos theta over cos theta is 1. And so now this is equivalent to our right-hand side. And so we've proven it this way. Nice and easy, soft. So we've done the proof. That's it. Nice and easy.